Hello everyone. Since there is a 21 days lockdown in our country, so I am uploading this video lecture such that the teaching learning process should continue without any kind of hindrance. So the topic for today's lecture is refrigerants part 1. In this PPT, we will study about the definition of refrigerant, then history of refrigerant, and then classification of refrigerants, and then the nomenclature of the refrigerants. Okay, so let's begin with our video lecture. So the refrigerant, it can be defined as a substance or mixture, usually a fluid, that is used in a refrigeration cycle to cool a space. Okay, so what is a refrigeration process? It is a process which maintains a given space at a temperature lower than its surrounding. So to achieve this cooling effect, the substance which is used is known as refrigerant. So it generally involves phase change. Okay, so it involves phase change as in the case of VCR system, but in air refrigeration there is no such phase change. Okay, so we can see over here. So this is a typical VCR system schematic. Here this is a compression process, then condensation, and then throttling, and then afterwards it is an evaporation process. So in case of a condensation evaporation, the refrigerant is going for a phase change. As in case of condensation, the refrigerant is converting from vapor to liquid. In case of evaporation, the refrigerant is converting from vapor to from liquid to vapor. Okay, so now let's see what is the history of the refrigerant. So the first refrigerant that was used was ether. In 18th century, the scientists have worked on the cooling effect using the chemical which is ether. Afterwards came air, which was used in the gas refrigeration. Then when the VCR system was introduced in the early 19th century, then the practical fluids which was used as a refrigerant were carbon dioxide and ammonia. Okay, but both carbon dioxide and ammonia has some limitations. Ammonia is considered to be a highly toxic in nature, and CO2, it requires high operating pressure. Okay, so in case of ammonia, if it is leaked, so there is a safety hazard for the operator. In case of a CO2, it requires very high operating pressure. Okay, so these were used for large cooling application like in meat industry or in the food industry earlier in the 19th century. Then afterwards there was the introduction of methyl chloride and sulfur dioxide. They are also toxic, but they was able to use for some small cooling applications also, like for domestic cooling methyl chloride and sulfur dioxide can be used. Then in early 1930s, CFCs or the chlorofluorocarbons were introduced as commercial refrigerants. So the first CFC that was introduced was R12. We will study about its nomenclature in the later in this PPT. So what are the advantages of the CFC? That they were non-toxic, non-flammable, and with good thermodynamic properties, and they were heavily used for domestic application. So even in our domestic cooling application, we have AC unit, we have a refrigerator. So in both this cooling unit we use CFCs. Okay, so but the CFCs, they have some good thermal properties, but these are not very environment friendly, as they cause ozone depletion, and this results in the global warming. So we have some treaty known as Montreal Protocol Treaty, which was signed in 1987, which aims at phasing out of all CFCs by 1995 and all HCFC, which is hydrochlorofluorocarbons, by 2030. Okay, so that R12 and R22, this has been phased out by 1995, and what we are using nowadays is R134A and R410A, which are HFCs, which is hydrofluorocarbons. So these have very less ozone depletion potential, that is ODP, and also global warming potential, that is GWP. Okay, so in this diagram you can see that this is the timeline for the refrigerant. So in 1900 there was an air cycle, that was air was used as refrigerant in the air cycle, and then came carbon dioxide and methyl chloride, and then the CFC, it was invented by Midgley in 1930, in 19 exactly to be 1928. Then afterwards came the Montreal Protocol in 1987. So this aims at phasing out of all the CFCs and HCFCs by 1995 and 2030 respectively. And then came the Kyoto Protocol. So what is this Kyoto Protocol? You can also Google this Kyoto Protocol. It is similar to your Montreal Protocol, where the countries aim at phasing out of the harmful gases which are causing greenhouse effects like carbon dioxide, methane, nitrous oxides. So that was Kyoto Protocol. Okay, so this is complete timeline for the refrigerants. Okay, now coming to the classification of refrigerants. So the refrigerant can be classified as primary refrigerant. Okay, so what is the primary refrigerant? These are the working mediums or heat carriers which directly take part in refrigeration system and cool the substance by absorption of latent heat. Okay, तो आसान भाषा में बात करें तो जो वीसीआर सिस्टम में आपका जो रेफ्रिजरेंट फ्लो करता है कंप्रेसर से होते हुए कंडेंसर, देन थ्रॉटलिंग डिवाइस, एंड देन बैक टू द इवेपोरेटर, तो वो जो रेफ्रिजरेंट फ्लो होता है दैट इज योर प्राइमरी रेफ्रिजरेंट. ओके, so example of those is ammonia, carbon dioxide, sulfur dioxide, freon group. Freon group is nothing but that CFCs, HFCs, etc. Okay, then this refrigerant can also be classified as secondary refrigerants. So these are those circulating substances which are first cooled with the help of primary refrigerants, and then they are employed for cooling purposes. So as in the case of ice plant. Okay, so if you have seen in your laboratory the demo of the ice plant, so उसमें क्या होता है कि आपका पूरा एक रेफ्रिजरेटिंग यूनिट होता है जिसमें आपका जो रेफ्रिजरेंट होता है R12 और R22 वो फ्लो करता है, और उसी में कंटेनर में आपका ब्राइन सोल्यूशन रखा होता है. ब्राइन सोल्यूशन नथिंग बट वाटर प्लस NaCl. ओके, तो ब्राइन सोल्यूशन का जो फ्रीजिंग पॉइंट होता है वो आपका 0 डिग्री सेल्सियस से कम होता है, अप्रॉक्सीमेटली -18 डिग्री सेल्सियस, डिपेंडिंग ऑन योर सॉल्ट कंसनट्रेशन. ठीक है, नमक की कंसनट्रेशन पे डिपेंड्स कि कितना फ्रीजिंग पॉइंट जाएगा. तो क्या होता है कि पहले आपका वो जो रेफ्रिजरेंट जो फ्लो कर रहा है फ्रॉम कंप्रेसर टू इवेपोरेटर, पहले वो ठंडा होगा, फिर उससे आपका जो ब्राइन सोल्यूशन है वो आपका हीट लेता है उससे, और क्या कहते हैं, और ठंडा होता है, सॉरी. सो जब उस ब्राइन सोल्यूशन जब ठंडा हो जाएगा तो देन इट वाज यूज टू प्रोड्यूसिंग ऑफ आइस. ओके, सो ऑल्सो यू कैन टेक द एग्जांपल ऑफ लाइक AC यूनिट ऑफ बिग अपार्टमेंट्स. ओके, सो उसमें क्या होता है, वी फ्लो वाटर एज अ सेकेंडरी रेफ्रिजरेंट विच टेक्स अवे द हीट फ्रॉम द building. Okay, and then this primary refrigerant can also be classified first as the halocarbons. Okay, so these halocarbons are nothing but the derivatives of hydrocarbons. Hydrocarbons which is given as CXH2X plus 2. So if X is 1, so it becomes methane, which is CH4, and if X is 2, then this hydrocarbon is known as ethane, which is C2H6. Okay, so halocarbons are the derivatives of hydrocarbons uh, by substituting hydrogen atoms with halogens, which is chlorine or fluorine. So what we do is substitute hydrogen with chlorine and fluorine. So these are colorless, non-toxic, non-inflammable, and non-corrosive. Examples are CCl4, which is R10, then CCl2, F2, R12. So this is known as difluoromethane, ethane, and then this is monochloro difluoro methane, and then which is R22. Okay, then HFCs we have R134A. Okay. Sorry, this is difluoromethane. Okay, and this is tetrachloromethane, R10. Okay, then the next classification is of hydrocarbons. So most of this refrigerant of this group are organic compound, that is ethane or methane, or you can use as propane, butane, ethylene also. So what is the main issue with this hydrocarbon, why we are not using this? Because it is highly inflammable. Okay, ये क्या होता है, ये आपका काफ़ी फ्लेमेबल होता है, लाइक आप इसको अगर ये लीक कर जाएगा तो ये आपके फायर हज़ार्ड कॉस्ट कर सकता है। ठीक है, तो इसको हम इसलिए ज़्यादा नहीं यूज़ करते हैं मीथेन एंड ईथेन को। इसकी वजह से हम वी गो फॉर हेलोकार्बन्स, और दीज आर आल्सो नोन एज हेलोजिनेटेड कार्बन्स। ओके, सो वी हैव another classification in this series, which is inorganic compounds. So example of inorganic compounds are ammonia, carbon dioxide, sulfur dioxide, and water. So inorganic compound, which means it does not have carbon hydrogen bonds. So the elements or the compound which have carbon hydrogen bond, those are known as organic compounds. So these were introduced before the hydrocarbon groups. Okay, like they were used in 18th and 19th century in meat industry, in food industry, and in the beer industry. They were used to store the beers in the big containers. Okay, so even today the ammonia is being used, but it is used only for the industrial purpose. It is not used for the domestic purpose, as it is very toxic in nature. Okay, so next classification, we have azeotropes. So this azeotrope is mixture of different substances. It is not a single compound, but it is a mixture of different substances, but they do behave like pure substance. So what is the meaning of pure substance? That the azeotropes has definite boiling points. Okay, they have single boiling point. They do not have a boiling over the range of temperature, but they have a single boiling point. Okay, but these substances, they do not separate by distillation. Okay, so distillation, as you know, that it is the process which separates liquids in a mixture by first evaporating and then by condensing. So these azeotropic mixture, they do not separated with the help of distillation. They do not get separated with the distillation. Okay, example is R500, which is a mixture of R12 and R152, having the concentration of approximately 74% and 26% respectively. So azeotropes, they start with 500 series. So any refrigerant which is of 500 series, that can be termed as azeotropes or azeotropic mixture. So the last classification of primary refrigerant is zeotropes or zeotropic mixture. So what is zeotropes? These are again mixtures like azeotrope, but they do not behave like pure substance. Okay, so azeotropes was a pure substance, but zeotropes are not a pure substance, which means they have gliding. Okay, note this point, they have gliding, evaporation, and condensation temperature. Okay, they do not have fixed boiling point, they have gliding range of temperature. Okay, we can say that is temperature glide. So example is R407C. So it is a mixture of R32, R125, R134A, having a concentration of 23%, 25%, and 52% respectively. So zeotropes you can identify when the nomenclature of refrigerant starts with 400. Okay, so azeotropes, the nomenclature starts with 500. For zeotropes, the nomenclature starts with the 400. Okay, so in case of zeotropes, the boiling takes place over the range of temperature, as already discussed. You may have studied in material science about alloys. So what happens in alloys, they do not have definite melting point. So the melting is taken place over the range of temperature. So you may have heard of liquidus temperature and solidus temperature. So solidus temperature is where the melting starts, and liquidus temperature is where the melting ends. Okay, so and also the phase change involves in alloys are solid phase and liquid phase, but over here in zeotropic mixture the phase change is between liquid and vapor. Okay, so similarly, as we have two temperatures in case of alloys, over here we have dew point temperature and bubble point temperature. So this temperature glide, it is a difference between the dew point temperature and the bubble point temperature of the zeotropic refrigerant mixture. So what is this bubble point temperature? Okay, so over here this is a bubble point temperature and this is dew point temperature. So what is the bubble point temperature? It is the temperature at which the first bubble appears, or you can say it is the temperature at which the phase change starts. यहाँ पे कौन सा phase change हो रहा है? Phase change हो रहा है आपका liquid से vapor में, ठीक है? So when the temperature reaches the bubble point temperature, the phase change of liquid refrigerant into the vapor starts. Okay, then as the temperature increases, the boiling takes place, and the boiling is completed at point B, which is dew point temperature. So what is dew point temperature? So it is the temperature at which the last droplet of liquid refrigerant evaporates, okay, which is the finish of the phase change. So now we'll see the nomenclature of refrigerants. First we'll start with saturated hydrocarbons based refrigerants. So these kind of refrigerants are those which have single covalent bond between carbon and hydrogen or any other halogens. The chemical composition of saturated hydrocarbon is CX H2X plus 2, as you can see over here. If X is 1, then we get methane, which is CH4, and if X is 2, then we get ethane, which is C2H6. Now these kind of refrigerants are designated as R, M-1, N+1, P, which have the chemical composition of CmHn, FpClQ, where the M is number of carbon atoms, N is number of hydrogen atoms, P is number of fluorine atoms, and Q is number of chlorine atoms. So for this kind of saturated hydrocarbons based refrigerant, the following condition must satisfy always, which is N plus P plus Q equals 2 times of M plus 2. Now this designation and condition over here is used for both saturated hydrocarbons and saturated halocarbons or halogenated carbons. So let us take the example. First example we are going to take is of dichloro-difluoromethane or CCl2F2. So what we have to do is convert this chemical composition of this refrigerant into its nomenclature. Okay, so we need to find the nomenclature of this refrigerant. So we'll compare this chemical composition, okay, with this formula, which is CmHn FpClQ. So we get that the value of M, which is the number of carbon atoms, is 1, and the value of N, which is the number of hydrogen atoms, is 0, and the value of P, which is number of fluorine atoms, is 2, and the value of Q, which is number of chlorine atom, is again 2. So now what will the designation? So designation of this CCl2F2 is R, M-1, where M is 1, so this is 1 minus 1. Then this is N plus 1, N is 0, so this is going to be 0 plus 1, and then P where here is 2. So that is we get R012, which can be written as R12. So the CCl2F2 is your R12 refrigerant. So now we'll take second example. Over here we'll do the reverse. We'll find the chemical formula of R22 refrigerant. So the nomenclature is given over here. We need to find the chemical composition in terms of C, H, F and Cl. So we can write this R22 as R022, and the values of M, N and P can be found by comparing R022 with the designation of saturated hydrocarbons, which is Rm-1 N plus 1 P, we get that m minus 1 is equals to 0. So m is 1 and n plus 1 is equals to 2. So we get the value of n as 1 and the value of p is 2. But here we cannot find the value of q. So for finding the value of q, which is the number of chlorine atoms, we will use the condition of saturated hydrocarbons, which is n plus p plus q equals to 2m plus 2. So we get the value of q as 1. Now we will put all these values in the formula CmHnFpClQ. So we get the chemical formula of R22 as CHClF2, as m is 1, which is number of carbon atoms, n is 1, which is number of hydrogen atoms, and the value of q is 1, which is number of chlorine atoms, and the value of p is 2, which is number of fluorine atoms. So this is monochloro difluoromethane. Since we call these kind of refrigerants as chlorofluorocarbon or chlorofluoro refrigerants, so we have chlorine before and fluorine is kept later. Okay, so now we'll start the nomenclature of unsaturated hydrocarbons based refrigerants. These kind of refrigerants have double covalent bonds between carbon and hydrogen or halogens, and the unsaturated hydrocarbons have chemical composition of CX H2X. So if X is 2, we get the chemical composition as C2H4, which is ethene or ethylene. So these kind of refrigerants are designated as R1, M-1, N plus 1, P, having the chemical composition of Cm, Hn, Fp, Clq. So the point to be remembered over here is that the designation of unsaturated hydrocarbons is always starting with 1. Okay, in case of saturated hydrocarbons, the designation has 3 digits. In case of unsaturated, the designation has 4 digits, which always start with 1. Okay, so for this kind of refrigerants, the following condition must satisfy, which is n plus p plus q equals to 2 times of m. So let's take an example. So we'll take an example of ethylene, which is C2H4. So we need to find the nomenclature or designation of this refrigerant. So over here we see that the number of carbon atoms, which is m, is equals to 2, and number of hydrogen atoms, which is n, is equals to 4, and there are no chlorine atoms or fluorine atoms, so the value of p and q is equals to 0. So now the designation of C2H4 can be found as R1, 2 minus 1, 4 plus 1, 0. Okay, where if we compare with this one, that is 2 minus 1 is nothing but m minus 1, 4 plus 1 is n plus 1, and 0 over here is p. So we get the designation as R1150. So now in this series, let's see the nomenclature of inorganic compounds. As already discussed, inorganic compounds are those which do not have carbon-hydrogen bonds. So these are designated by number 7, followed by the molecular weight of the refrigerant, which is rounded off. For example, if we take air is also a refrigerant. The molecular weight of air is 28.96, so we round it off to 29 over here. So let's take an example. Let's take the first example of ammonia, having a chemical composition NH3. The molecular weight is 17, so the designation will be R717. Okay. In case of carbon dioxide, chemical composition is CO2, molecular weight is 44, so the designation is going to be R744, that is 700 plus 44, that is 744. So in case of water, the chemical composition is H2O, molecular weight is 18, so designation will be R718. So this is all for today's lecture. Next lecture in this series is Refrigerant Part 2, which will deal with properties of refrigerants, selection of refrigerants, and application of various refrigerants. Thank you for watching. Have a good day.